Authentication protocols and services. Let's begin. I'd like you to think back to the last time that you logged on to your bank online, or if you have never logged on to a bank online, maybe a social media website. In any case, the company that you're logging onto, it's very likely that they have hundreds or even thousands of servers. And when you connect to one of them and they ask you to log in and we supply our username and maybe a password or maybe some kind of a PIN or special information, it can then authenticate us. Now, the question is, how in the world does that specific server, we'll call it server A, how does it know who we are? I mean, there's so many servers. Do they push our credentials and our information to all of the servers? And the answer is no. Not every server has information about you and I and our username and password, but every server does have access to a centralized database of users and passwords. So for example, maybe the server's right here. So the centralized server has all the usernames and passwords. So when you or I try to log on to server A or server B or server C, that server makes a request over to the centralized database of usernames and passwords. And this centralized database then gives the thumbs up or thumbs down regarding is our password correct or not. And that way, the company doesn't have to keep our username and password specifically on each and every one of their servers. They use a centralized database for that storage. Now, a funny thing happens when we connect to a bank or other online site that we're going to do a transaction with. They want to know who we are, so they are going to require us to authenticate. And that authentication really is two basic parts. There's the ID part, where we'll say, this is my username, and there's also the verification part, which we might do by supplying our unique password that we set. And the combination of our identity and the verification, or our passphrase or password, is what we commonly refer to as authentication. And in information systems, we have a common theme called AAA. Now, even today, when I see AAA, I think of the Automobile Association of America. But with information systems and computer networks and systems, the AAA stands for authentication. That's the first of the AAAs. The second A is for authorization. And the third A is for accounting. And we can also think of accounting as auditing. It's very similar. Or accountability, which is also very similar. And a great example of AAA would be either going online or physically walking into a bank. They want to know, before we do a transaction, who we are. So they use step number one. They make us authenticate. We provide ID, a password, perhaps a banking card that we have. And once we've been authenticated and then we want to do a transaction, the second thing they're going to do is make sure that we are authorized for that. For example, if we say we'd like to take out $1 million or 1 million euros or 1 million whatever, they're not just going to give it to us. They're going to make sure that we are authorized to get it, meaning do we have that much in the account, what's the limits on withdrawals, and so forth. And let's say we are successful in withdrawing 1 million euros or $1 million or 1 million Bitcoin or whatever it is. The third step of AAA is they are going to account for that. It's going to be recorded as a transaction that occurred. And they'll also debit our account based on that $1 million or 1 million euros or 1 million BTC that we withdrew. Well, the same concept of AAA applies to our networks as well. When you and I connect to a network or a system, it's very likely they're going to want to authenticate who we are with some kind of a username password combination. And then, after we're connected to the system, we don't just have full access to everything. For example, maybe we're logged on to a local PC, and that local PC, we have limited rights. We don't have full access. Now, regarding what we do have access to, the process of authorization comes into play. So if we try to access a file or a resource or install a program, before it lets us do that, it's going to verify whether or not we are authorized for that activity. And if we are, it simply lets us do it. And if we aren't, there's going to be some kind of an error message that comes back. Or maybe a message saying you don't have enough rights to do this. Or whatever the programmer of that system configured as the message to come up when the person who's authenticated has insufficient rights or permissions to do some task. And the third step in most secure systems is going to be some kind of an accounting system. So let's say that this is Bob here at the PC, and Bob is installing some software. The system knows who he is. Let's say he is authorized to install software. He has the permissions. He installs the software. There's very likely going to be an accounting record that recorded that Bob installed this software at this time. Or if Bob is accessing a database or some other resource, accounting records and auditing records could and should be tracking that activity. So if we have to go back and do forensics and take a look at what happened on our system, we can identify that Bob logged in at this certain time, he accessed these resources at that time, and while he was logged in, he did actions X, Y, and Z, and then he logged off at some later time. And all of that would be part of an audit trail because of accounting features. Now, to kick this up a notch, let's say that Bob has some various needs. For example, maybe from time to time, Bob needs to access the company resources through the public switch telephone network. So that's just a phone line. Maybe he's got an old modem or something to that effect. So he's using a phone line connecting to a RAS server. RAS is simply a generic acronym. It stands for Remote Access Server. It's the server that allows people remote access. I've also seen this referred to as a NAS, Network Access Server. And it doesn't just have to be dial-up. We could also have VPN capabilities and call that a network access server as well. At other times, Bob may be accessing the corporate network via the internet. So maybe he has DSL or cable modem at his house, and he wants to use that connection to connect to corporate headquarters. We might have a VPN server that Bob can connect to. And we could use SSL/TLS or IPsec for a secure virtual private network going over the internet to this VPN server, which could then give Bob access to internal resources. Now, these two solutions are for when Bob is not physically on premise, but maybe Bob is actually at the office some days. And when he's at the office, he also might want to go ahead and connect to the network on the local virtual local area network. So maybe his PC is connected through Ethernet to an Ethernet switch. And the last scenario on this page anyway is when Bob takes his PC, his laptop, disconnects it, and connects via wireless. That's another mechanism that he might want to use to go ahead and connect to the corporate network. Now here's our challenge that you and I have. Every time Bob connects to the network, whether it's through a remote access or a VPN server or through a local Ethernet switch or through wireless, we need to make sure we're playing the game called AAA because we are concerned about security. And we want to authenticate every single individual who is connecting to our systems, whether they're coming in through the public switch telephone network, wireless on a switch, or through a VPN server. So just for a moment, let's say that Bob's username is Bob and his password is VPN exclamation mark 7 pound symbol BATE. And that's a pretty good password. We have upper and lower case, alphanumeric, special characters. And just for a moment, let's say that is his password and his username is Bob. That's his identity. Now the question is, where do we store this information if we want to authenticate Bob, regardless of which method he comes in? And it's possible that we could store that information on each of these devices, depending on the vendor and the technology. But that's a hassle, especially if Bob ever changes his password. We'd have to go back to each of these devices and change Bob's password if he wanted to be able to use those methods to access the network. So to solve that, we're going to use some type of centralized database for usernames and passwords. And an example of that is right here with this AAA server. And a AAA server could be called lots of things. It could be called the Authentication server. If we're using a protocol like Radius to communicate with that AAA server, it's often called a Radius server. If we're using TACAX Plus, which we'll talk about here in a moment, we might call that same server a TACAX server. And really, all this is a centralized clearinghouse, if you will, where we do have information about users like Bob, passwords like Bob's password right here, and we could also specify authorization information on this server. As an example of authorization, let's say that Bob is only allowed to use VPNs on weekends, meaning he's only allowed to connect to the corporate network via a VPN over the internet on weekends. On this AAA server, it could be configured that, okay, for Bob, here's his username, here's his password, and if he's coming in through this VPN server device, he's only allowed access, he's only authorized to use the VPN server for connecting to the network on weekends. So that, my friend, is an example of where this second A comes into play for authorization. It's controlling not just the authentication portion as far as identifying who Bob is, but it's also controlling authorization of what Bob is able to do and when. And the third thing that this AAA server can do, it can also keep accounting records. So let's say Bob does log on through the VPN server The AAA server can keep those accounting records. So if we ever had to go back for any reason and look at the details of who logged in, when they logged on, how long they were there, and so forth, we could go to this one AAA server and look at the auditing logs or the accounting records that are stored on that server for all of those details. So let's imagine that you and I are going to set up this environment where we have this centralized database of usernames and passwords and what those users are authorized to do, as well as a centralized location for accounting. How do we pull that off? Now, the great thing about standards and the standard way to set this up is that there are so many to choose from. But one of the most popular methods of using a centralized AAA server is to use a protocol called Radius. And Radius is an acronym for Remote Authentication Dial-In User Service. And we're going to implement this Radius protocol between, for example, the remote access server and the AAA server, between the VPN server and the AAA server, between the Ethernet switch and the AAA server, between a wireless access point and potentially a wireless LAN controller, which is controlling the access point, and the AAA server. And that, my friend, is where Radius is played. The Radius protocol runs between a device who needs to find out, hey, it's Bob, is he valid or is he not valid? And the AAA server who has the answer. So what you and I would do is we would pre-configure this VPN server and tell it, hey, buddy, if you ever need to validate users, go ahead and use the Radius protocol and talk to this server at 10.0.1.5 or whatever the IP address is of that AAA server. And the same thing for the Ethernet switch. If the Ethernet switch was using 802.1x to authenticate devices before it allowed them to connect and send traffic through the network, this switch would be configured as a Radius client, which means we're going to tell this switch, hey, Mr. Switch, if you ever need to validate Bob or anybody else, because you're using the 802.1x protocol with that client, go ahead and send those Radius requests over to 10.0.1.5, and he'll give you the answer, yes or no, as far as Bob and the credentials that Bob supplied. And the same thing for a wireless client coming in. So Radius, in effect, is the language of love between a AAA server that could be called, in this example, a Radius server, because we're running Radius between it and the Radius clients. So this RAS device would be a Radius client. The VPN server would be a Radius client. The Ethernet switch would be a Radius client. The wireless LAN controller or the access point would be a Radius client. And then Bob out here on the internet is the user who's trying to get in. So when Bob comes through the public switch telephone network, maybe we're using PPP as our protocol. When Bob tries to come in over the internet with the VPN, perhaps we're using IPsec there. When Bob is trying to authenticate coming in on the local area network, we're using Ethernet and 802.1x to authenticate that. And for the wireless access, we could use 802.1x or 802.11i. Those are both possibilities based upon the infrastructure that we have set up for authentication of our wireless users. And then for these segments in blue right here, we would be using Radius. Now, Radius is based on UDP at the transport level. And depending on which flavor of Radius you're using, it could be using either 1812 for the authentication portion and 1813 for accounting, or it may be using 1645 and 1646. Again, based on how old and what flavor of Radius is being used. Now, the traffic that goes back and forth across these blue segments here between the Radius clients and the AAA server is not all encrypted. So if we put a wiretap on one of these network segments and listen to it, we could see most of the traffic in plain text, except for credentials. Credentials are being encrypted, and that's a good thing. So Bob's password, whatever it is, if somebody was eavesdropping on one of these blue segments here where Radius was running, the password-related information would be encrypted. It would not be in plain text. So the attacker or eavesdropper would not be able to decipher the passwords in use. And the reason it's so popular, Radius is because it is an open standard. And it does support authentication, finding out who that user is, authorization, what they're allowed to do, and the accounting. And all that information regarding the authorization and the accounting information, it's all typically stored right there on the AAA server. Another cool thing about a AAA server is that let's say Bob is terminated from the company. We want to make sure he has no access anymore. If we have a AAA server deployed and all these devices are asking that AAA server every time Bob tries to authenticate, by simply telling the AAA server that Bob's account is disabled or setting up his authorization so that he has no access to anything, that's a very quick way of shutting Bob out if he's attempting to log in via any of these mechanisms. The other cool thing about Radius is that besides authenticating users, we can also authenticate network devices. And because it's an open standard, it's not proprietary. Maybe we've got some routers and switches and firewalls from various vendors. If those devices support Radius, and most of them do, we can tie them into our centralized Radius server and use our existing Radius server with multiple vendors' products, which is pretty darn cool too. Now, Radius has been around for a long, long time, and sometimes with technology, we come up with like better ideas or different ways of doing things. And so there's another protocol, it's called Diameter, and it also is a AAA protocol, meaning it can support authentication, authorization, and accounting. And I think the name was a little bit of a joke or a jab in the fact that a diameter is twice the radius. So in the development of that, there was some humor involved. But effectively, Diameter is just another AAA protocol that we could use in place of Radius if all of our devices supported it. So our AAA server would need to support Diameter. Our network devices would need to be able to communicate via Diameter protocol. And one thing I will mention about Diameter is that it does support something called EAP, which is the Extensible Authentication Protocol. And by using that, we have some new commands and attributes that makes it more flexible. And I suppose time will tell if Diameter will become the replacement for Radius in the future. Because it, like Radius, is also an open standard. It's not proprietary. And again, time will tell how well it's going to be adopted. Now, Radius and Diameter are not the only AAA protocols out there. There's also something called TACACS. Now, there was an original TACACS that was called TACACS, and there's an RFC for it. And then Cisco made some enhancements to it, and they called it X-TACACS. And then the final evolution, or the current evolution of TACACS, is called TACACS Plus, and it is completely proprietary from Cisco. It is not an open standard. And so today, anytime somebody refers to TACACS, we are going to presume they're talking about TACACS Plus, because the older X-TACACS and the original TACACS are simply not used anymore. Now, TACACS being another AAA protocol, though it's proprietary, it actually is an acronym that stands for Terminal, Access, Controller, Access, Control, System. And that is such a mouthful, that's why everybody and their brother just refers to it as TACACS, which is a AAA protocol, so we can use it to support authentication, authorization, and accounting. However, we're typically only going to find this being used in Cisco environments with Cisco devices because it is Cisco proprietary. And if our RAS server and VPN server, Ethernet switch, and our wireless gear was all Cisco, we could use TACACS between each of those devices and the AAA server that is currently running TACACS. So if we compare and contrast TACACS versus Radius, TACACS at the transport layer, layer 4 of the OSI reference model, uses TCP. The well-known port is 49 for TACACS. With TACACS, again, I'm referring to TACACS Plus, which is the only TACACS that we use today. So the original TACACS, the enhancement to TACACS called X-TACACS, and TACACS Plus. And by the way, they're not backwards compatible. Regarding encryption, TACACS is going to encrypt the full session between the TACACS client and itself. For example, if this is our AAA TACACS server, and this VPN server is using TACACS, this VPN server would be acting as a TACACS client. So the play-by-play would be this. Bob is trying to authenticate with the VPN server using IPsec, and then the VPN server turns around and makes a TACACS request to the AAA server saying, hey, I've got some credentials for Bob. Are they correct, and is he allowed to connect, and so forth? And then if the answer is yes, there will be a TACACS response back to the VPN server to indicate 2 thumbs up. Let Bob in. Now that entire TACACS session is encrypted. So if somebody's eavesdropping on a TACACS session between the VPN server and the AAA server, if they're running TACACS together, the attacker is going to see the IP addresses involved at layer 3. The attacker will also see the port of 49 in use for the TACACS traffic. But as far as the application layer data, all the payload, it's all encrypted. And because the attacker wouldn't have the keys in use regarding that encryption, the attacker wouldn't be able to make sense of what the messages were back and forth between the VPN server and the AAA server. And that is more secure than Radius, because Radius is only encrypting the password portion of the communication, where TACACS is encrypting the entire session, every packet. The payload is being encrypted. And because it is proprietary, we're likely to see this only in Cisco environments with Cisco gear. And typically, here's how I've seen TACACS and Radius implemented over the years. If we're authenticating users, like end users, like Bob, it's very likely that we're going to be using Radius. So I'm going to put end users. And I found that's also true even in a Cisco environment, where we'll often use Radius, even on Cisco-capable devices, for end user authentication. With TACACS, typically what we're going to see is admin. I'm going to put admin users as well. For example, on this VPN server, if Bob is trying to authenticate just to get access to the network, it's very likely that Radius is going to be configured between the VPN server and the AAA server to authenticate that end user. However, let's say that you, and I mean you specifically, let's say that you are the administrator of the system and you want to log on to the VPN server to manage that server, change policy, change the configuration, etc. The authentication of you, in this case you being the admin, it's very likely in a Cisco environment that we're going to use TACACS for administrator authentication. And one of the reasons is we can be more granular as far as authorization with TACACS. And that is one of the great reasons for using it for authenticating administrators. Because maybe we want you as the administrator to have certain rights and permissions to work on this VPN server, but not everything on that VPN server. So for example, if you log on as the administrator, you're authenticated via TACACS, and then every command you type in as you work on this VPN server, before those commands are executed, this VPN server is feeding them down to the AAA server saying, hey, he's executing this command, and now that command, and the other command. Is that authorized? Is that authorized? Is that authorized? And with our AAA server, it can respond back to that VPN server saying, yes, he's allowed to issue that command, take it. Or, no, he's not allowed to issue that command, take it. And that's the authorization piece of a AAA server. And TACACS, when supported, just does a better job of the authorization portion. It's more granular. And then third, because it is a AAA server, every time you, as the administrator, are making a change, it can send an accounting record right back to that AAA server. And whether we're using Radius or TACACS, our VPN server here could be sending back accounting records that would be stored right here on this AAA server. So by centrally managing our authentication and our authorization and our accounting, this is a fantastic place right at the AAA server that we can go to review user rights and permissions and what people are allowed to do or not allowed to do and what they did do and what they didn't do, all centrally at that AAA server. One other thing I want to mention regarding Radius, TACACS Plus, and Diameter is that they are all AAA protocols that support authentication, authorization, and accounting. And we could use Radius and TACACS and Diameter with or without other protocols. For example, let's say we have Microsoft Active Directory, which is using Kerberos, which we'll talk about here in a moment. Kerberos is not a prerequisite to use Radius or TACACS or Diameter for the authentication, authorization, and accounting for remote users and services on our system. We can use it either with a Kerberos network or we can use it completely separate. The two are not required. There's no link that requires Kerberos, for example, in order to use Radius or TACACS. Kerberos is an authentication protocol, not a AAA protocol, just authentication. And where we'll normally see Kerberos in use is in Microsoft Active Directory. And here's the problem that Kerberos can solve. Let's take our user Bob. He's sitting very happily at his computer, not logged on yet, but about to be. And we have a centralized server, very likely a domain controller, and this server is going to be acting as a KDC. That's a Key Distribution Center. And let's say this blue rectangle here represents our Active Directory domain. And let's say we have a couple other servers, maybe some file servers, or other devices that Bob may need access to. So on these file servers, we've set up access control and access control lists that say, okay, Bob is allowed to have access to certain files or directories for read or write access or full access. Now the challenge is, how do these file servers know that Bob is really Bob? And one of the big benefits of Kerberos is that we can support something called single sign-on, where Bob can authenticate once and then get access to all the resources that he's entitled to that are part of the domain without having to re-log in to server 1, 2, 3, or 4. And the way that Bob does this is he's going to initially authenticate with a key distribution center. And the key distribution center has a service running called the ticket granting service. So let's say that Bob wants to go to file server number 1 here in green. Before he goes out there, he's going to send a request to the ticket granting service saying, hey, you know what? I've already authenticated. I've proven who I am already. I need access to file server number 1. The ticket granting service is actually going to grant Bob a ticket that Bob can now present to file server number 1 that will tell file server 1, hey, by the way, this is Bob. And then when file server 1 validates that ticket and knows that this really is Bob, file server 1, now knowing it's Bob, can go ahead and give Bob access to those files or directories for which Bob has been given permission or rights to. And similar activity would happen if Bob needed to go to file server number 4. Bob would go to the ticket granting service saying, hey, I need to get to file server number 4. The ticket granting service would issue Bob a ticket, and then Bob would present that ticket to file server number 4, and then file server number 4. And now file server number 4, now knowing the identity of Bob, could go ahead and allow access or deny access based on the permissions and rights that Bob has been given to the files and directories on file server number 4. And the cool thing about this is that Bob only had to log in once to the KDC, prove who he was, and then all the tickets that are being issued in the background don't require Bob to re-authenticate every single time he wants to go to a new server. Now, tickets do expire, so after a period of time, very likely hours, Bob may have to re-authenticate again, which is a good thing. Because we wouldn't want Bob to be able to log in, for example, January 1st, leave his computer on, and still have that be a valid session all the way through December 31st. There's very likely some security flaws with having a single user logged on constantly that long. So Kerberos uses a key distribution center. Microsoft's Active Directory uses Kerberos in their domains as the authentication protocol. The KDC is going to be issuing tickets through a service called the ticket granting service. And it's these tickets that allow Bob to identify himself to the other servers and devices in the domain. And the tickets are granted from a centralized location. Now, in a big network, we're likely going to have multiple domain controllers and multiple key distribution centers for fault tolerance purposes and for scalability. But from an architecture perspective, we do have a centralized location, this key distribution center, that's going to be distributing these tickets, which effectively are going to be granting access to users like Bob to the resources they need. The other thing that's really cool about Kerberos is that not only are we authenticating Bob to a server, but we're also using encryption. And it happens to be symmetrical encryption that are going to protect the content of the communications between Bob and server number 4 or between Bob and server number 1. And any time that we do encryption, specifically symmetrical encryption, we're using the same key or some kind of a shared key on both ends to encrypt and decrypt that data. So although primarily Kerberos is used as an authentication protocol, it also brings to the table secure communications between devices inside the domain that are using Kerberos, with a primary example being Microsoft's Active Directory. And the port that Kerberos uses is port number 88. LDAP is an acronym for Lightweight Directory Access Protocol. And let's say, for example, we have Bob. Now, Bob is in a container called sales, an organizational unit called sales, under the domain name of acme.com. And this is simply a structure, an x.500-like directory structure of objects inside of Active Directory. Now, somebody who is really smart decided, well, you know what? We've already got Bob as a user object inside of Active Directory. We want centralized management of user accounts for access to the network and resources. Why bother putting Bob as a user account also in AAA? Why not just leave him in the Active Directory and have that be our mechanism for authenticating users? And then the problem was, well, how do we get to it? Well, one option was we could have our RAS, our VPN server, our Ethernet switch, or our wireless devices connect directly with this Active Directory using a protocol like LDAP. And so that's what they did. Another option is this. Maybe we have a VPN server that only speaks Radius or only speaks TACACS. So let's call this Radius right here for this red link. And maybe what we do is we have our AAA server. instead of creating Bob's username and password locally there, maybe we use LDAP to communicate between the AAA server and our LDAP server. And by the way, Microsoft's Active Directory and its servers can provide LDAP services. So this link right here would be using the LDAP protocol. So now when Bob tries to connect, maybe he'll initiate an IPsec VPN tunnel over the internet to the VPN server, who says, hold on a nanosecond, I need to check and see if your credentials are right. The VPN server could forward that request regarding Bob and his credentials down to the AAA server. The AAA server could say, hold on a microsecond, let me send that request over to the LDAP server. And if the authentication is successful, we'd get a positive message back from the LDAP server over to the AAA server, who would relay that positive response via Radius up to the VPN server, and that would make for one very happy Bob, because he's now been authenticated and he can have access into the system. So LDAP is simply a protocol that's used for authentication services. We might have a system that can talk directly via LDAP to an LDAP server, or we might have to go through an intermediate device, like a AAA server, who can then speak LDAP to the LDAP server. LDAP uses port 389, and as you can imagine, the LDAP server isn't just going to let anybody make a request. This AAA server, for example, would be configured as an LDAP client. We would specify exactly what username and password to use when it makes those LDAP requests. And then, when the requests come in and they're accepted by this LDAP server, it can look up the information, for example, regarding Bob, give a thumbs up or thumbs down, based on the information supplied regarding Bob and either Bob's passphrase or password. And then if it's all correct, we get a thumbs up from the LDAP server coming back, which would correspond to the AAA server telling the VPN server that it's okay, let Bob in. Now, one of our challenges is, what if somebody's eavesdropping on the communications between our AAA server and the LDAP server? Normal LDAP on port 389 is not encrypted. However, what we can use is we can invoke TLS/SSL, the same technique we use to protect and make secure sessions between a browser and a web server. We can use that same feature along with LDAP, and they call that secure LDAP. And secure LDAP uses port 636. So standard LDAP is port 389, and secure LDAP is port 636 at the transport layer. I'd like you to imagine that you and I are going to plan a trip. So we go to Google and we do some searches, and we find a screaming deal on airfare. And then on the way out, as we're checking out, it says, oh, by the way, do you need a hotel? Do you need a car? And the hotel and the car may be from completely different vendors than who's selling the airfare. However, what they can do is that once we're authenticated via the airfare company, they can automatically pass the authentication over to the hotel vendor and the car vendor and make it very easy for us to complete our transaction, instead of having to go to 3 different sites, authenticate to 3 different sites, and make individual purchases. Now, how in the world did they do that? Well, there's more than one way they could have pulled that off, but one method could be using something called SAML. And SAML stands for the Security, Assertion, Markup, Language. And it allows you or I to log on to the primary website one time and still do business with other websites that are affiliated with that first one. So behind the scenes, what's happening is the actual authentication data is being shared between those various sites. So if these are 3 separate companies or 3 separate domains, if you will, the authentication and authorization information regarding us from the primary site is being shared with the other 2, so we can complete our transaction and make it easy for the user. So from the SAML perspective, us, you and I, we are the principal in this transaction. And I believe that's spelled A-L. My dad used to be a principal of an elementary school, and he said, the way you spell principal is P-R-I-N-C-I-P-A-L, because the principal is your pal. And that's how I remembered it. And there is a different word, principal, with P-L-E. For example, someone would want to base their financial decisions based on sound principles. That's with a P-L-E at the end. In any event, with SAML, we would be the principal. This primary company that we connected to would be the identity provider. And these other sites that are getting the authentication information about us would be considered service providers. And I'm going to add over here, or Bob, just to remind you that the principal is the actual user themselves, which could be Bob or us if we're logging on to the primary site, which is the identity provider, where we've authenticated, we've been authorized, And then the identity provider is passing on our credentialed information and the data regarding our authorization down to the service providers. I have had a great time with you in this video, and I'm glad that you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.